NASA is making history with its Parker Solar Probe. This historic probe is about to be like Icarus, where it plans to fly towards the sun, except this time it has no plans to get burnt. The probe plans to fly right into the sun's corona, getting closer than any object before. After it plans to send out a beacon, which will inform scientists of the current status, giving reassurance that it's okay. According to Nicola Fox, a NASA Associate Administrator for Science Missions, the Parker Solar Probe has achieved what we designed the mission for. Right now, the Parker Solar Probe is flying closer to a star than anything before and is on the correct orbit based on mission parameters. As of this video, the Parker Solar Probe has gotten close, almost too close, to the Sun, flying within 3.8 million miles, or 6.1 million kilometers, of its surface. The probe touched the Sun on Tuesday. The probe is flying at around 430,000 miles per hour. From a perspective, that is like reaching Tokyo from Washington, D.C. in less than a minute, according to what NASA scientists mentioned. While a quick trip, according to agencies during a December 16th NASA Science Live presentation, this probe will be the fastest object made by humans in recorded history. A historical mission, this one has been monitored by many scientists and space fanatics alike. The probe launched on August 12th, 2018, at an event attended by Dr. Eugene Parker, the astrophysicist the probe is named after. Dr. Parker was one of the first researchers in the field of heliophysics, hence the apt name. He is also the first person alive to have a spacecraft named after him. Although Parker died in March of 2022, he was still able to see the launch of this historic spacecraft. Over the last 6 years, the Parker Solar Probe has collected some enlightening data about the Sun. Already, in December 2021, the probe touched the Sun by flying through the corona, known as the upper atmosphere, to sample the particles and magnetic fields within the Sun. Over the last 6 years, heliophysics has learned amazing mysteries about the Sun, how solar wind is created, and why the corona of the Sun is hotter than the surface itself. Scientists also plan to learn how coronal mass ejections, which are big clouds made of plasma, ionized gas, and magnetic fields that erupt from the outer atmosphere of the Sun, are made. Understanding these ejections allows us to better understand the root cause of geometric storms, which are major disturbances that occur on Earth's magnetic field and impact communication infrastructures and satellites. The Parker flybys are impressive on their own, and according to Helene Winters, they are changing the field of heliophysics. The spacecraft has already taken a beating, braving heat, dust, and blasts of solar radiation, yet it continues to survive while providing valuable data to inquisitive heliophysics. The flyby is the first of many approaches, with Parker planning to approach the Sun once again on March 22nd and June 19th. To put into perspective how close the spacecraft got, if the distance between the Sun and the Earth was like a 100-yard football field, the spacecraft is in the equivalent of 4 yards from where the end zone is. So yes, it got really close. All the while, the Parker Solar Probe must survive plasma and solar eruptions from the Sun, along with dust and debris, not to mention extremely hot temperatures. It's getting close, and it's getting hot, so you might wonder how it's managed to fly this close to the Sun. The corona's particles and energy are incredibly hot, higher than 1,000,000 degrees Fahrenheit, while also beating radiation that would incinerate a person so quickly you couldn't imagine. How does it not melt? Well, it's because of the shield that's on there. Parker Solar was made for the heat and to withstand some of the hottest temperatures and most dangerous conditions in our solar system. Through an autonomous heat shield system, the probe is able to withstand the extreme temperatures and conditions for the mission. This custom heat shield protects the probe from intense light, while also allowing the coronal material to interact with the spacecraft so scientists can get important data. It seems confusing at first, but there is a scientific meaning behind why it won't melt. The concepts of both temperature and heat are different. High temperatures don't always mean that the object will heat up. Space is different from our world. We feel hot when it's 100 degrees. In space, it could be 1,000 degrees, but the spacecraft won't feel hot. That's because temperatures measure the speed of particles. In contrast, heat is the energy transfer of these particles. If there are many high-moving particles, high temperatures result. On our planet, for example, there are tons of particles, and they interact with each other. They move at high temperatures, which means that more energy is transferred, hence the hotter temperature. Space is a little bit different. There might be super fast-moving particles, but far less than on our planet. Space is devoid of life, so there are very few particles in general. The energy transfer is far lower, so it will have low heat. The sun's corona is super hot. Think 1,000,000 degrees, but there are very few particles in density. The probe is flying through a giant oven with fewer particles, which means it can withstand much longer periods of time before it melts. The corona is less dense, so you're not interacting with hot particles as much. It's like putting an object in boiling water in the oven. With boiling water, it melts or cooks much faster. In contrast, the oven takes a lot longer, hence fewer particles. Sure, it's traveling through million-degree spaces, but the shield will only get to around 2,500 degrees. It's still really hot, but not enough for the probe to melt instantly. The shield is about 4.5 inches thick and around 8 feet wide. Prior to being launched from Earth, it was tested, and scientists found it would withstand temperatures of 2,500 degrees Fahrenheit. This shield was made through a carbon composite that's sandwiched in between two plates made of carbon. It is lightweight, but insulates well, and also has white ceramic paint as a finishing touch to reflect more heat. In the lab, this was tested and found to withstand temperatures of 3,000 degrees Fahrenheit, so it will handle what the sun throws at the craft with ease. Because the spacecraft is traveling through low-particle, high-temperature areas, the interior is not affected. In fact, because of this shield, the objects inside, including scientific instruments and electronics, will stay at room temperature. If there are problems, a cooling system will pump water through the craft's solar arrays to keep the craft around 320 degrees Fahrenheit during the approach. The craft is autonomous because if a crew were sent up there, it'd be far too hot for them to get near the sun. I wouldn't want to be up there since, well, thousands of degrees is still hot. In fact, lava is cooler than this. Along with the shield, there is a solar probe cup poking out, designed to measure electron fluxes and ions along with the flow angles from the solar wind. Because of the intensity of the atmosphere of the sun, new technologies must be engineered to make these instruments survive. The solar cup is made from an alloy of molybdenum, titanium, and zirconium, which melts at around 4,260 degrees Fahrenheit, and the grids are made from tungsten, which melts at 6,192 degrees. Researchers assembled these instruments using particle accelerators and IMAX projectors rigged to increase the temperature, mimicking the sun's heat. These projectors expose the instruments to various radiation. The probe cup and the shields were both made to withstand these intense temperatures and whatever solar emission the sun throws its way. The Parker Solar Probe is set to approach the sun, and after the approach, Parker will let mission control confirm the success. The beacon relays the spacecraft's stats, but the images won't be available until Parker is away from the sun's orbit, set to occur sometime in mid-January. The mission is unprecedented and might give us more information about the sun's state. With the sun entering a solar maximum cycle, this mission has a chance to see some of the most impressive highs and lows transitions ever recorded. During this cycle, the poles flip and the sun becomes active, with major aurora displays seen across the world. Learning more about these sunstorms and how they affect our planet allows us to gain incredible insights into the activity of one of the brightest stars in our solar system. No matter what the sun throws at Parker Solar, the probe plans to deal with it accordingly. So go ahead, keep flying close to the sun.